The structure question related to atomic physics, usually the last question you will find from atomic physics. So this question is the isotope of americium, which is 241, is represented by a symbol 241, 95, and AM. This isotope decay by alpha emission, like it is emitting out alpha particle. Complete the nuclide notation. So you can use a screen annotation to complete this. You can use screen annotation or a chat to complete this. The nuclide notation. For a nucleon, whenever alpha particle is 4 and 2, nucleon number decreases by 4 and a proton number decreases by 2. So this will be 93. That's right. What about the nucleon number? If it is 241, the nucleon number decreases by 4. So if it is 241 minus 4, that's equal to 237. And the nucleon number for alpha particle is 4. And the proton number is 2. The next part, figure 10.1 shows a simple diagram of a smoke detector. The smoke detector contains a small piece of americium. So there's a radioactive source, americium is there. The isotope ionizes the air between the metal plate in the detector. Describe how americium 241 ionizes the air. You can see like this is americium, like radioactive source. What it emit out? It emit out alpha. And when we compare the ionizing power or ionization power of alpha is more than beta and beta is more than gamma. And main reason is that because it has a greater mass and charge. But we have to explain how it ionizes the air. So it is given in the question that this americium is emitting out alpha. When you check the previous part, so they mentioned that it is emitting out alpha here. Like an isotope decay by an alpha emission, so emitting out alpha. So when it emit out alpha, what will happen? When it emit out alpha, what will happen? This alpha is having a greater mass and greater charge. So as a result, when it has a greater mass and greater charge, it can easily knock out the electron from an atom. So how it cause the question is how it cause an ionization. That so how you explain how the particle can cause an ionization, and it's of 3 marks. So what happened? First, the americium emit alpha particles. That is 1 mark. It's already there, but we have to identify. So americium is emitting alpha particle, and alpha particle is having a greater mass and charge. So it collide with electron, or it collide with air particles or air molecules. And as a result, it will knock out electrons from atoms or molecules. So what actually happened? Like the americium is emitting out alpha particle, which is 2 proton and 2 neutron. And there are air molecules. Like this dot is representing a nucleus, and then the shells, and they have electrons. So when these alpha particles collide or interact with an atom or the electron, they knock out this electron. They remove this electron. As a result, it produces a positive ion in electron, and it ionizes the air. The term ionization means removal of electron. So when these alpha particles, they collide with a the atoms or the molecules of air, they remove the electron from the molecule or the atoms. How we know it was an alpha? Because that was given in the question. In the beginning of the question, they specify that this americium is emitting out alpha. That's how we know. Because they mention here the isotope of an americium, isotope decay by an alpha emission. So means this americium turn into neptunium and it emit out alpha. And this alpha interact with the air particles and it knock out the electrons from the air particle, which cause an ionization. That's how we identify that there was alpha. The next suggests and explain two reasons why a smoke detector use an isotope that emit alpha rather than it emit out gamma. Like why we don't use an isotope which is emitting out gamma. Number one, because
Because alpha
yeah, yeah,
can ionize the air
easily, yeah,
easier.
yeah, highly ionizing, easily compared to gamma. That is one thing. What else? High energy can cause cancer in human. Okay. What else? Like, yeah, you can mention less harmful. Yeah, gamma passes straight through. Like gamma will not cause any ionization. Because how this smoke detector is working, what is the working principle of this smoke detector? So it is working simply that, for example, in this is the airflow, like airflow from here. In case of a fire, there will be smoke particles. Like first a radiation, the alpha source is emitting out like radioactive source is emitting out alpha particle. This alpha particle ionizes the air, and the ionize or the charges move towards their respective electrode and produce a current. But what happens if in case of a smoke or in case of a fire, there will be smoke particles. When these smoke particles are there, alpha cannot pass through these smoke particles, so it cannot cause an ionization. So as it does not cause an ionization, this detector circuit will record like no signal, so the alarm will work. It is emitting out. So like these are the two electrodes. And here we have a radioactive source. The radioactive source is emitting out radiation. This is causing an ionization. It is continuously causing an ionization. And these ions move towards their respective electrodes. So the signal, it gives that output signal that like there is no fire. But what will happen in case of a fire? There will be smoke particles. And when there are smoke particles, alpha particles cannot penetrate or pass through this smoke particle, so it cannot cause ionization to the air. When it does not cause ionization to the air, so the smoke detector does not record any signal, so it give an alarm or an alarm will ring that smoke detector stop working and it shows that there is a fire or there's a smoke. Alpha particle cannot ionize the smoke particle because alpha particle have the least penetration power. They cannot pass through the smoke. Even 4 to 5 centimeter in air, it can only pass through. So two reasons why we use alpha, because it has a greater ionization compared to gamma. And the second reason, less harmful compared to gamma. If we use beta, then there are possibilities. Sometime it will pass, sometime it won't pass. So maybe alarm will work in different scenarios. So beta, it might work, it may not work. To both possibilities are there. But gamma, once there is a smoke, it won't ionize the air, so it will stop working and the alarm will ring. And gamma, if we use gamma, then it will continue to like pass through, so it won't change even there's a fire or no.